I'm Roberto Baldwin, and this is Tomorrow Today's Sustainable Mobility Brief. The transportation world is evolving at a rate not seen in decades. The transition from fossil fuels to sustainable energy has brought with it some truly exciting opportunities, but also some confusion. I'll sift through the noise and share quick updates on the latest news, trends, and advancements that will impact our world for years to come. This week on the Tomorrow Today Briefs podcast, we have Keenovo co-founder and CEO Nadeem Maalouf. Nadeem, thank you so much for joining me today. And today we're going to talk about something I think most people don't really think about, and that is the software that runs batteries. I think most people just think of a AA battery. You shove it in probably not a Walkman, but the remote control in your house now, and it's just, electricity comes out and that's it. When we're talking about batteries in vehicles, batteries in the grid, batteries in eVTOLs, even batteries in our phones now, that is a completely different setup. And so let's talk about what Keenovo is doing for, everything from personal electronics to transportation to grid balancing, especially as the world that's increasingly reliant on batteries.
Well, first, thank you, Roberto, for having me on the podcast today. Appreciate the opportunity. So in essence, as we electrify and decarbonize away from fossil fuels, we're moving towards electricity as being the primary energy source. And unfortunately, with electricity, you got to store it to use it properly. And that's where the batteries come in. The last 100 years, we've been relying on lead-acid batteries, but they don't do the job. They just don't have what's called the energy density to store enough energy in a certain volume. And that's where lithium-ion batteries came in about roughly 40 years ago in the 80s when they were first commercialized by Sony. But for 30 plus years, there were mostly those little tiny batteries that went into your camcorder or you went into your, ultimately, of course, your smartphone, the iPhone, the Android, but never to the scale that was demanded by electric cars. Where, just to put it in context, an EV would have roughly between 5,000 to 8,000 smartphone equivalent batteries in there. And so it's a huge scale. And then when you move to storage, we'll talk about storage a little bit like a truck or beyond that. We're talking about yet another factor of 10 or even 100 beyond that. And so you create a number of complexities when you put so many batteries together. How can you operate them efficiently? How do you operate them economically? How do you operate them safely? And how do you extract what ultimately customers and drivers desire, which is, hey, I don't care what the battery does. Can I get 300 miles of driving? Can I charge it in 15 minutes or less? Will it be safe? These are fundamental things where the intelligence and the software comes into play. And that's kind of what we do. It's that intelligence layer, that software layer that sits right next to the battery in the vehicle, in the smartphone, in the grid storage, that essentially does a bunch of things. It's sort of measuring what the battery is doing, and then using that intelligence through measurement to close the loop, to take certain actions to improve the performance and the economics and the safety of that battery. It's
sort of insane when you think about it because, let's talk about the Polestar 2. The Polestar 2 came out. It had a range that was under 250. The same battery, the same vehicle via a software update jumped up to like 230, 240. It increased its battery capacity or its range via software. And I think that sort of boggles the mind when you think about it, because again, most people just think, well, I plug my phone in or I put a AA battery in a thing. So software is changing everything, and it's not just it's increasing range on your vehicle after you bought it is a huge deal.
Indeed, I wish I could sort of say somebody has a magic wand, but no one does. Ultimately, physics do prevail, and I can explain some of the fundamentals behind that. So when you're building an EV, and Polestar or anything else, doesn't have to be the Polestar, could be any EV in that matter, batteries usually are not fully utilized in the EV. So let me be specific. Let's say a particular EV has 100 kilowatt hours of energy nominally in it. In reality, only about 80 to 90 kilowatt hours of that is accessible to you for driving. The rest is not accessible to you, mostly for longevity purposes, because you have to meet that 10-year warranty or 100,000+ miles of warranty. And so the car makers end up reducing the accessible energy. It's like reducing the size of your gas tank or how much fuel you can put in a gas tank. So when your technology begins to improve through things like us, the software, for example, and we can say, hey, I can actually give you the longevity that you need without sacrificing that much energy in the battery, then I can give you more access to it. So that essentially, instead of accessing only 80 kilowatt hours, we might raise it to 90 kilowatt hours or even 95 kilowatt hours. And that translates to more miles to you for driving. So it seems like magic, but in reality, it's not. It's just opening up the envelope of operation.
And another aspect is extending the life of the battery, the amount of charge cycles. One of the big issues with solid state batteries is that the charge cycles, they just haven't gotten there yet. It's not good for large scale, but for the lithium ion batteries, everyone, there's the concern. The concern is like, well, after 5 years, those batteries are no good. You lose X amount. Like, tell me how software has helped extend the life of.
Yeah, software is absolutely crucial in that respect. And so today we routinely run 1,000 to 2,000 cycles on a car or even a smartphone. And so batteries are finicky. And the amount for a two-terminal device, for a simple device that is the battery, plus minus, you think, how complicated can it be? It is insanely complex inside. The electrochemistry, the stuff that's going on is very, very complex. What makes it even more difficult is that no two batteries are ever born equally. When you go through a manufacturing process, same factory, same line, same everything, and the batteries will come out ever so slightly different. And so software becomes crucial to make sure that we can control that behavior, understand the tiny defects that may exist in the batteries, and begin to optimize the performance of the battery to extract the highest amount of longevity. Similar example, perhaps, in a human world. We're all born sort of similar in many ways, but how we live our lives determine whether you live to be 50 years old or to live to be 100 years old. What you eat and what you drink and what you breathe, etc., contribute to your longevity. And the battery, in a very simplistic way, is similar to that one. So the software becomes crucial in making sure that the battery adheres to a certain regimen that maximizes its longevity. And once you maximize the longevity, it opens up massive other attributes. For example, you can now fast charge without damaging the battery. It's like if you're healthy as a human, you can run. If you're not healthy, you can barely limp. And the same also when it comes to accessible energy. So it means your driving range increases. And once you increase that performance envelope, another thing happens. The economics become more favorable. Because as you increase the cycle life, the longevity of the battery, I now need smaller batteries to get the same object or the same objectives. And therefore I can save 5, 10, 15% of the cost of the battery. That may not sound a lot, but for an EV, that's $1,000 or even $2,000.
Yeah, the most expensive part of an EV is the battery. And it's the fact that if you say 10, 15% on that, that's a huge, huge savings. And
massive.
And it also, that trickles down to consumers who are looking to, for that, a lot of, we talk about the sub $30,000 EV right now as sort of I'm not going to say the magic bullet, but something that'll help adoption to extend the market. And so being able to software, use software to make the batteries better means that you can put fewer cells inside of a battery and fewer modules and still get the same performance.
Absolutely. Look, I think what we've seen in the last decade in terms of EVs has been wonderful, but we're not going to decarbonize the world by selling Teslas and $50,000, $80,000, $100,000 cars.
Yeah, definitely.
We need to get that down to affordability for everyone. And affordability also does not mean you can sacrifice or compromise performance. You can't say, I'm going to sell you a $25,000 EV, but sorry, your range is only 100 miles. That's not going to fly.
Yeah, it's this weird thing where we're looking at trickle down technology is essentially what.
Right, and that's exactly where software comes in, because the materials limits are well known, and it's the software that comes in and opens up that envelope, that extra 10, 15, 20%. To really make it affordable, economic, and also reach the metrics that the drivers do care about.
Yeah, that's great. Software is essentially like the nutritionist and the personal trainer of batteries.
Indeed.
Like it keeps you going.
Yeah, exactly.
So let's talk a little bit about something I think some people know about, but is energy storage within the grid. We're seeing Tesla and some other companies, they have these large energy storage centers or locations that are essentially replacing peakers, which are these usually high polluting, used at the last minute power stations that utilities will spin up when there's huge demand. And if you can do that with just a bunch of batteries, that makes more sense economically, but also, for the environment. How does the working environment of those batteries differ from, say, an automobile? And how is the software, is it the same sort of software? Is it different software? How does that work?
Yeah. So first, let me talk about the driving forces that is really amplifying the need for electric storage. First thing is you've got, as you mentioned, the peakers. And the peakers, specifically what it is we generate a huge amount of electricity from renewable sources, typically when the sun is shining. But when the sun sets, well, we don't have the means to store that energy and then use it at nighttime. That's where the batteries come in to shift that peak and essentially use the stored energy from the midday to in the evenings. But also there are other things that are taking place in addition to that peak shifting. And that is you've got increased demand for electricity. If we were today to electrify all hundreds of millions of cars in the US on the road overnight, we would need to increase our energy generation by 50%. So it's a huge amount of energy that we need. And of course, you get AI coming down the pike. That's yet another big driver. So there's a huge need for energy, and we need to create that energy typically when the renewables are active, and therefore the storage becomes crucial. The fundamental science behind a smartphone battery or a EV battery or a truck battery or a storage battery are exactly the same. The use case differs. For example, in a passenger car, most of the time it sits in your garage. You drive it perhaps a couple of hours a day, but for the most part, it sits in the garage. A truck, it's not. The truck is being driven virtually 365 a year, 24/7, massive use cases, cold, hot, fast charging. It's a very different use case, which means it's putting a lot of stress on the battery. In the grid storage, it's yet another different use case. It actually sits idle most of the day because you're charging it slowly from the renewable, and then comes onto the grid for a few hours at night, between typically after sunset, call it 6 to 10 p.m. And that's when now you're sourcing that. The other interesting thing about energy storage is that you're not limited by volume. In an EV, your volume is limited. Whereas in the case of storage, if I need an extra, half an acre of space to add more batteries, so be it, we can do that. Yet, across all those, you also have the common element of safety. When you put a battery in your backyard in a community, and you've got now, maybe a couple of acres of battery storage, if these catch fire, it's a big problem. And so the safety becomes very crucial, equally important. So there are many common features, but also there are some differences in use cases. But the software is almost universally the same. The fundamental science behind it is exactly the same. It's how you apply the software. For example, where do you put some limits on the voltage and the currents? Where do you put voltage or safety limits? At what point in time do you invite the maintenance crews to come in? All of that kind of comes into play. Remember also that unlike the EVs, the storage system is maintained by an entity, not by drivers like you and me. There's a utility, there's an operator, there's someone. So there's a different degree of maintenance requirements for this particular site.
Yeah, and because of the software, they can real time see how these systems are doing. They can see when there's...
Absolutely, and that's exactly where we shine. So we're trying to basically give the users, whether the drivers or the operators of the storage sites, the ability to look at all the batteries in that massive site individually and understand which one of them may require maintenance or replacement in the next few weeks or few months. And that makes the economics far more attractive.
Wonderful. And now the next frontier of batteries is aerospace, eVTOLs, the essentially the giant drones that'll replace helicopters, I think, is the main sort of what those vehicles are looking to do. Is it sort of the same situation with, is it a little bit different just because, because there are FAA requirements that might be a bit more stringent than, say, the Department of Transportation? Does the software have to change? Does the software have to...
A little bit. So the challenges of flying is that, let me go back to an EV. Worst case car runs out of battery, you stop cold. An airplane runs out of battery, we have a big problem, right? We got a big problem. So I think there are some safety implications, and these reflect themselves onto the nature and the characteristics of the batteries. For example, weight matters in flight. It matters in EVs, but not as much as it does in flight. And so what's called energy density becomes crucially important. You need more energy density for flight. Cycle life does matter, but more so in a car than in a drone because you can always swap out the battery. So that's sort of less important. So you start looking at those compromises, how the use case drives the different specifications of the batteries, and they begin to diverge a little bit between flight and driving. We're not yet where we need to be for sustained flight. So what we're talking about here are limited durations, half an hour perhaps, 45 minutes, short distance. In California, maybe from San Francisco to San Jose, and in New York, maybe from LaGuardia to JFK. These are short distances. We're not anywhere near yet to replace a 777 Boeing flying from JFK to London Heathrow. That's not going to happen, at least not in the foreseeable future. But can you deliver, for example, goods? That's a possibility. Now you see in drones that are electrified to deliver goods. Safety is important. The economics are still not there yet. I think if you look at EVs, we're awfully close to the economics of EVs matching and potentially surpassing those of combustion engines. We're not there yet when it comes to flight.
We're almost there with parity. So close with EVs. I see it.
Yes. Yeah.
Well, thank you so much, Nadeem, for talking with me today. I really appreciate it. I think a lot of our listeners are really appreciative, just sort of like demystifying what software is doing with vehicles. And again, why, if they bought an EV and then 6 months later it got a little bit better, now they know why.
Thank you for having me.
For more information about the evolution of sustainability, head on over to sustainablecareers.sae.org. And if you're not quite ready to add an EV to your household, you can check out our plug-in hybrid explainer video to help bring you up to speed on the hybrid technology and the vehicles. Be sure to subscribe and listen every week on your favorite podcast platform.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.